Hi friends, welcome back to the next session on the process management. Now we come to an interesting topic, virtualization. So what virtualization is, why it is important, and how scheduling comes into picture, all that is what is our next items to discuss. So let's imagine a situation where we have one system and there are multiple users and each user having multiple tasks. So in all we have one system. One system means it is working with one CPU, that is one type of CPU, one brand of CPU, and on that the system is working with one operating system, and we have multiple users, and each user may have many tasks, and the problem comes when all the tasks may not be comfortable with the same operating system which is currently working with that particular system. And to aggravate the problem, we have another situation issue that all tasks may not be comfortable with the same CPU type. So in all, what is happening is we have one CPU, on that there is one operating system, and we have many users. Each user may be working with many tasks, and the problem with each task may want to work on different operating systems. Each task may want to work on different type of CPU. Then what is the solution? What is the solution? The one positive side of this is we are talking with the human users. We are talking with that whose response time is quite slow compared to the machine's response time, and hence multitasking can be taken up. But only issue here is each user, each task may want a different type of CPU to be used. They want to use different type of operating system to use, and that is where a simple multitasking cannot help us here. Then what we can do, let's see. So what we have with us, we have one hardware that we can't change. That is what we have with us. That is one type of CPU we have. It may be Intel CPU, it may be AMD CPU, it may be Android, or it may be iOS, whatever CPU we have. Yes, we have one. Then it is working with one operating system. It may be Windows or Linux or whatever, don't know. Yes, it is the system we have, and that system has got a hardware, that is processor and other peripheral devices. Yes, it has come with it. So we just can't keep changing them as per the request of the users, as per the requirements of the task and all that, but we need to find out some way out, and that's what we are now into. So what we can do now is we can create one more layer on this, what we call is hypervisor, and this hypervisor hides all the lower layers. That means it hides the operating system from the users, it hides the operating system from the task, it hides the hardware underneath from the users, it hides the hardware underneath from the task. So this is creating an illusive environment that what you want we have. So that creates an illusion that we have a machine which is what you wanted. Say user 1 wanted one type of machine, then yes, we say that we have that machine. That means it is using the CPU what user 1 wanted. But in fact the actual CPU what is available with the system may not be the same as the CPU which the user wanted. But yes, we can somehow convince the user that we have the same CPU what you wanted. So what we need to do, this hypervisor has to act like a translator, the language of the CPU which is actually present. So let us call it the physical CPU. So it should act like a converter, translator from the language of the physical CPU and the language of the virtual CPU, that is, which doesn't exist, but for the user it looks like it is existing. So we have created a virtual environment saying that whatever you wanted, we do have that. So in that, what we can do in this what we call virtual machine, we can say that which CPU you want, yes we do have. Which operating system on which you want to work, yes we do have. So this hypervisor acts like a translator between the two ends. So user wants one type of CPU, we have one type of CPU in reality. So virtual CPU, real CPU, there is translation required, yes we are doing through hypervisor. Then we have a CPU, an operating system which is installed physically on the system, and the user wants some other operating system. Then instead of saying no, let us say that you have your own operating system with us, so nothing to worry. So we create an environment as if the whole system is working on that particular operating system. That means this virtual machine will consist of one virtual processor and another operating system which is not the one which is there here. So to differentiate this, let us give some nomenclature to that. The actual CPU available with the system, let us call it physical machine, and the one which we have created as a illusion to the user, let us call it virtual machine. The physical machine consists of one type of CPU, and the physical machine comes with one type of operating system installed. And under the virtual machine we have a translator that translates between the language of the physical CPU and the virtual CPU. And as in case of operating system, let us call it this, we can't call it physical one, so let us call it host operating system. And the operating system which the user wants, so let us name it as a guest operating system. So let us assume that we wanted two different environments. So two different environments are created in which the virtual machine 1 VM1, virtual machine 2 VM2. So the two environments are created, and let us assume that VM1 works on one type of CPU and VM1 wants one type of operating system. So we have a virtual processor under VM1, and we have one guest operating system in VM1. Same way under VM2 we have one virtual processor and one guest operating system, and below the hypervisor we have the host operating system and the physical processor. So on top of that we have users, tasks and all that which interact with these virtual machines. So this is the concept of virtualization. So let's see what a virtualization is as a definition. So it is one which has a common hardware. We have multiple users. Each user wants to work on a different hardware, maybe Intel, AMD, Texas Instruments, Nvidia and all that, and each one wants to work on different types of operating system, maybe Linux, Windows, Unix, of his or her own choice. So the traditional ones says that there is one hardware, there is one operating system, on that we have applications, but our virtual architecture says that there is one hardware, on that there is a virtualization layer. On top of that, each virtual machine has got its own operating system. So for each user it appears as if working with one thing that the whole system is their own, and other thing is working on their own liked environment and all that. So that's the advantage of working with virtualization. So here the virtualization is the process of creating virtual version of something like hardware, operating system, or storage. Multiple isolated environments called virtual machines, or in short we call it VMs, can run on a single physical machine. That's what we just wanted earlier. And the software that enables all these activities to take place smoothly is what we call a hypervisor or virtual machine monitor, so in short VMM. So here this gives a better picture of what we are talking about. So we have a shared hardware resources on the bottom, then we have a hypervisor, and then we have a guest operating system, and on top of that applications are running. That is, application means the tasks are running. So this talks about one user or multiple users. So various tasks are running through API calls. So they interact with their guest operating system. The guest operating system will interact with the hypervisor, and hypervisor in turn will interact with the shared hardware resources like shared memory, shared CPU, and all that. So that's virtualization. And then coming to virtual scheduling, we have multiple tasks, and multiple tasks want to work on different types of machines, different types of operating systems. So this whole thing has to be somehow scheduled. So there are basically two types of scheduling required. One is the virtual machine scheduling, and the other one is the task scheduling. So multiple virtual machines share the same physical CPU. Each virtual machine thinks that it has its own CPU or no CPUs. A hypervisor must schedule the CPU time across all the virtual machines. Inside each virtual machine, the guest operating system must schedule tasks for the processes or the threads. So what we have, it's double complicated. That one side we have a set of virtual machines working, and that virtual machines should be allotted CPU time, that is a physical CPU time. So that is done by the hypervisor scheduling, and inside each virtual machine the guest operating system must take care of scheduling the processes or threads. So this process scheduling, thread scheduling and all we have seen earlier. It is same as what we discussed earlier. This is that one operating system, and there are multiple processes and they are working on that. So that is then we have two levels of scheduling: the virtual scheduling by hypervisor and process or thread scheduling inside the virtual machine. So that's what we have seen now. So hypervisor scheduling schedules the virtual machines, and the guest operating system schedules the task inside that. So that's hypervisor schedules entire VMs on the physical CPUs. Guest operating system schedules threads or processes inside that virtual machine, and the hardware executes what is assigned by the hypervisor. It doesn't know anything about the guest operating system. The hardware doesn't have any information about how many users are there, how many processes are there, how many threads are there. Nothing. Everything is hidden from the hardware. The hypervisor is assigning all these things. So it is the duty of the hypervisor to maintain the fairness and all details about scheduling. So types of virtualization scheduling: the space scheduling. Each VM gets exclusive access to core of a time slice. Time sharing, it is time multiplexed. Fair scheduling, that is shared CPU time equally based on weights. Then real-time scheduling is reserved CPUs resources for critical virtual machines or tasks. So the challenges what we find in virtualized scheduling is double scheduling problem. Guest operating system may think a thread is running, but hypervisor might have paused the whole virtual machine. So that is one problem, because finally hypervisor has to allow one virtual machine to get the access of the CPU, and the guest operating system has allotted one thread or a process to run, but the whole virtual machine is paused by the hypervisor. Therefore the guest operating system doesn't know that it is not working. Then the performance interference, one VM may slow others down, noisy neighbor problem and all that. Timekeeping is another problem. Virtual CPUs need special support for accurate clock timers, and fairness and priority. So maintaining a balance between fairness and the priority is a big problem when we work on virtualized system. So friends, that's it in the second module. Please have anything to know more, please contact me on the given addresses, and please do like, share, comment, and please subscribe to the channel. Thank you.